Good morning, students. How are you? I hope you are fine at home. As you are aware of this coronavirus disease, and because of this, lockdown is increasing day by day. So, our school has decided to start the online classes for all the subjects. So, last year you were having the general science. Now, this year in 9th standard, you will have Science 1 and Science 2 in two parts. So this year I am going to take Science 1, that will include physics and chemistry. So I will send you videos in having with subtopics. Okay, so let's start with the first chapter. Good morning all of you. Now today we are going to study the first chapter of the Science 1, and that is laws of motion. Motion, what does you mean by motion? Motion is nothing but a movement of an object. Okay, now here the subtopics are there: motion, acceleration, distance and displacement, Newton's laws of motion and related equations. First, motion of an object. Now you see here some examples are given to you. Now in which of the following examples can you sense motion? How will you explain presence and absence of motion? Now see, 4 examples are given. Just you have to tell in which case you are feeling sense of motion and in which case there is absence of motion. First, the flight of a bird, or the bird is flying. So this is the sense of motion. Example of sense of motion. The second, a stationary train. A stationary train is a train at rest. Okay, not moving. So this is the absence of motion example. Third, leaves flying through air. This is also an example of sense of motion. And a stone lying on a hill. This is the example of absence of motion. Now we see the motion of several objects every day. Sometimes we cannot see the motion of an object directly, as in the case of a breeze of the air. We cannot see the motion, but we can feel it. Can you list other examples of motion beside those given here? Can you give any examples? For example, you see the rotation of our earth. With the rotation of earth, then you see the revolution of this moon also. In the rotation of the earth we can see, but we cannot feel it. Okay, we know that there is a rotation of earth is going on, but we are not able to feel. Okay, now think about it. You are traveling in a bus. Is the person sitting next to you in motion? No, it is not in a motion. Second, what do you take into consideration to decide if an object is moving or not? It is its displacement. You have learned that motion is a relative concept. If the position of an object is changing with respect to its surrounding, then it is said to be in motion. Otherwise, it is said to be at rest. So, we can say an object is, if it is changing with the respect, if its position of an object is changing with respect to the surrounding, then it is said to be in motion. Otherwise, it is said to be at rest. Okay. Now, next topic is displacement and distance. Now, we will see what is displacement and what is distance. Now, to understand this concept clearly, one activity is given to you. Okay, what is that? Now you see here in this figure, you see here two houses are there. Okay, and one school is there. Okay, now what they are telling us: measure the distance between point A and B in different ways, as shown in figure 1.1a. Here it is. Okay, so you see, to A and B, they are 2 points. So they are asking us to measure the distance of this between these 2 points. So two possibilities are there. One is that dotted one. Okay, we can measure this one also, and we can measure in this manner also. Okay, so now measure the distance along the dotted line. Which distance is correct according to you and why? Okay, now see here, if we are measuring this dotted line, so we will get this short distance. Okay, we will get the length of this A and B, that is will be short. And if you are going to measure this in this manner, in the line drawn, so that is you will get somewhat long distance. Okay, so actually you see this concept dotted one is called as the displacement. Okay, we will come to know this afterwards. And this line, this if we are going, it is called as the distance. Actually we see we are having the habit, for example, if you are going by a road, if you want to go from one place to another, if you are going by a road, so that we can have a long way, okay, long distance, but this is shortcut only. We can say this is shortcut to go from A to B. Now next activity is there. Think about it. You see here, just now I told you that these two houses are there and school is there. This house belongs to Sheetal and Prashant, and this house belongs to Sangeeta. Okay, now you see in the first case, Sheetal first went to her friend Sangeeta's house on her way to school. So you see, Sheetal started she want to go to school, so she went first to her friend's house, and then they both gone to the school. Okay, so they covered 500 meter plus 1200 meter, that is 17 meter 100 meter distance. Okay, then Prashant went straight from home to school. So Prashant directly went from his house to the school, so he covered 1300 meter distance. So who will take less time to reach the school and why? So as we know that Prashant has taken the less time, 1300, and this both Sheetal and Sangeeta, Sheetal has taken the 1700 meter distance, long time. In the above example, is there a difference between the actual distance and the distant travel? What is it? Okay, so there is a difference between actual distance. Okay, the actual distance was 1300 only, but that difference is about 1700 minus 1300, that is 400 meter difference is there. Okay, now see here, distance is the length of actual path traveled by an object in motion while going from one point to another, whereas displacement is the minimum distance between the starting and finishing point. So already we have seen. Now second example is given. Every morning Swarali walks around the edge of a circular field having a radius of 100 meter as shown in figure 1.2a. If she starts from the point A and takes one round, how much distance has she walked and what is her displacement? You see Swarali make one round about this circular. Okay, so the radius is 100 meter. Okay, but as you see here, they are asking us what is the distance. So we can calculate the distance by, we know that the formula 2 pi r. Okay, radius we are already having, and 2 pi also we are having 3.14 the value, and 2 we have to just 2 pi r. And what actually you see here, the swirly start from A and again reach here again to that same point. So here no displacement is there. Okay, now you see, consider the second example. If a car starting from point P goes to point Q, see figure 1.2b, and then returns to point B again, how much distance has it traveled and what is its displacement? You see here they are telling the car starts from point P. So you see the car start point from point P, goes to the point Q, and again it returns back and end at point P. So the distance, you see the distance of one side is given 360 meter. So again it will come, so it will be 360 plus 360 meter, that will be 720 meter. And see if the body or the car has came to the same point again, so that there will be no displacement, only distance is there. So even if the displacement of an object is 0, the actual distance traversed by it may not be a 0. Okay, so understood? Thank you.